We're just going to do a little exercise here on Ohm's law, that we're going to make a prediction about how much current a relay is going to use, and then we're going to verify that by calculation. We're going to measure it. So we're going to just check out both of these things here, and we're going to use just a standard multimeter. So if you just show the relay there and explain what's what. Just explain that with the coil, yeah.
We'll be connecting the circuit up from the 85 to the negative, and then to the 86 to the positive, and checking the resistance, which will give a current, a magnetic force, which will close the relay switch and open it when released.
So the first thing we want to do now is measure the
ampage, resistance.
Okay, we can measure. Well, which is it? Which do we want to measure first?
Measure the resistance first and ampage.
So measure the resistance of that fella first. So 86, 85. So the black lead always goes into the common. You don't have to worry about that. And then if you look down here, you'll see, I'll put a picture of this up. You can see here what goes in here, and resistance is one of them. So in goes your red lead there. And all he's going to do is go across terminals 86 and 85. Now we're expecting a resistance of around 150 ohms, something like that. So we just go onto a 200 scale, and we're going to measure the resistance. It's jumping around slightly. We're going to call that 90 ohms. So 90 ohms there, resistance is equal to 90 ohms, right? And the next thing we need then is the voltage on the battery. So you need to change the voltage. We're expecting to see around 12 volts. So we need an exact voltage. So we're just going across the terminals of the battery, and we are getting 12.5 volts. So V is equal to 12.5. So now we're just going to plug those fingers into Ohm's law. So there's Ohm's law there. We're just going to plug them in, and the amount of current that should flow on that circuit, I, is equal to the voltage divided by the resistance, which is equal to 12.5 divided by 90. And because we're working in base or base derived units, my answer is going to be in amperes or amps. So 12.5 divided by 90 .
0.13.
0.139, let's call it. So we're going to call it 0.139, and we're going to stay in amps, but we're just going to write down in brackets there what that is in milliamps. So it's 139 small m big A. That's it. Perfect. 139 milliamps. We're going to stay in amps. So that's what we're expecting to see. So now we're going back to our relay here. Now be very careful about this one. Is that there? So this thing here is marked for, what's that one marked for?
The milliamps fused.
Right, so milliamps fused, so make sure you go into that there, and then go on to your milliamp scale. So we're expecting to see around 140 milliamps. So we've gone on to amps, DC, and 200 M, that's milliamps. Right, so we know that's going to cover it. Now one terminal on the relay is going to be grounded, so there you can see the ground. Right, you go ahead.
Now we're connected to the 85 for the earth in the relay.
Okay, good stuff.
And we are going to...
I'll hold the live on for you. So we're coming from the live.
And when I connect this onto the 85 now, you'll see the switch. The magnetic current is pulling the switch closed. And you'll see on the multimeter 124 milliamps.
124.5 sometimes, so let's call it 125. Okay, so 125 we've measured. So how is that predicted? We've measured 125, we predicted 139, so let's see the difference there. So just draw a line. 5 and 9 leaves 4, and 2 from 1 there. So we're out by 14 milliamps. Now the thing is, there are slight variations. That meter is not that accurate. That meter is accurate plus or minus 2%, as are all the meters. So we're out 14 thousandths of an amp, 14 thousandths. Now we can't measure down that accurately. In other words, Ohm's law, yeah, it's true. We're predicting pretty much what sort of current we're going to get. There's a slight difference there, 14 milliamps. Like, in terms of the accuracy that we can attain, it's an absolutely bang on result. And that's it.